Hello students, in previous lecture we have studied about the unit cells and their different types of unit cells in crystal lattice, and we have already discussed about that the number of atoms or number of unit cells present in given mass of that crystal, and the formula which is related with the density of that substance, molar mass of that substance, as well as age length of unit cell of which that crystal is formed. Then, and numerical examples which is based on those formulae we have solved in the previous lecture. Then today we are going to discuss about the few new concepts which is related with the crystal structures or crystalline substance. Generally you observe there are different crystalline substances present in the nature, or we use the lot of crystalline substances in everyday life. Those crystals, it may molecular solids or ionic solids or crystals, or it may be elemental crystals, that is here metallic crystals or covalent crystals. Then those crystals which we observe in the nature or everyday life, no any crystal is perfect crystal. That means, what is the meaning of perfect crystal? Then see here, all of you studied about that. There is a regular arrangement of the ions or atoms or molecules in the crystal structure. That means, in crystalline substance, there is a orderness or regularities in the arrangement of those particles or spheres. Then see here, there is a specific arrangement or perfect arrangement of those spheres or particles present in the crystal. But see here, there is a regularity in the arrangement of those particles. Particles means atoms, molecules or ions. Then there is a regularity at a particular limit, but beyond that limit there is some irregularity present in the crystals. That means here there is few defects or imperfections are there. That is called as crystal defects, or it is also called as imperfections present in the crystalline substance. That means, for example, see here, if it is a crystal of NaCl, that is common salt, then there is a regular arrangement of Na plus Cl minus are there. That means here cations and anions which are arranged at a particular order, and that orderness which is present in that common salt crystal, it is not perfect. Then it is a perfect up to a range, but there is some irregularities in the arrangement of those cations and anions, and that irregularity which is present in that arrangement of particles in the crystalline substance is called as crystal defect. For example, in NaCl crystal there is absence of anion as well as absence of cation. That means there is a irregularity seen or observed in that crystal structure. That means there is a imperfections, that is the crystal defects. then that if there is a regular arrangement of the particles and there is a perfect orderness of those particles takes place in the crystalline substance, then that crystal is known as perfect crystal. Perfect crystal. And in perfect crystal, no any defect is there, no any imperfections are there. That means there is a particular orderness of the arrangement of the constituent particles present in the solid crystals. But it is not true for real crystals. You observe the different crystalline substances in everyday life, that those all are real crystals, and those real crystals should contains any defect in the arrangement of those particles or atoms or molecules. That is the defect in the arrangement of those particles or molecules or atoms in the crystalline substance, and therefore that crystals are called as real crystals. Then see here, real crystals, those are not perfect crystals, and here the defects which is created in the real crystal. For example, I have discussed with you that there is some vacancies, that means absence of few cations and anions or particles or atoms or molecules in the crystalline substance. Then see here, there is absence of particles are there, and in few there are cations or anions or particles which occupies the interstitial space. That means there is irregularity in the arrangement of particles. There is also irregularity in the arrangement of particles. That means here, see here, in this substance there is a regularity of the arrangement of particles in that crystalline substance, and no any irregularity is there. That crystal is called as perfect crystal. But there is few irregularities in the crystal structure. That means like that absence of particles in the crystal structures, or there is a particles which occupies the interstitial space. Interstitial space, that is voids or empty space of constituent particles in the crystalline substance. Then that irregularity should be there in the real crystals. That means in real crystals we observe the crystal defects, and those are called as crystal defects or imperfections. That means here the perfect crystal do not have any defect, and if that perfect crystal is there, then it is formed at absolute zero temperature. That perfect crystal formation takes place at absolute zero temperature, and that absolute zero means it is a minus 273.15 degree Celsius temperature, which is known as 0 Kelvin. That temperature is known as absolute zero temperature, and at this temperature the arrangement of that particles, constituent particles in the crystalline substance is perfect. Therefore perfect crystal formed at absolute zero temperature. Sometimes there are defects are formed above that temperature, above the temperature of that absolute zero temperature, or about this temperature crystals have defects. That means sometimes the defects are formed purposely. Why that defects are formed purposely? Because to create or to maintain the desired property or to obtain the desired property in that crystalline substance. For example, here the atoms of copper are arranged in the metallic crystal of copper, and when we mixed zinc atom into it, then that zinc atom which occupies the interstitial space into copper, and here that defect formation takes place purposely to form the alloy. Here copper plus zinc, that alloy is known as brass. Brass is an alloy which having different properties than copper and then from zinc. Then those alloys are used for production of utensils or the coins of that brass or few articles of those brass alloys. Then see here purposely that defect is formed by formation of alloy. When that defect is produced during the formation of that alloy has a desired property which we require for production of utensils and coins, and that property is not present in zinc. Therefore that defects sometime it created purposely. Then we will discuss about how many types of defects are there in the crystalline substances. Then see here that defect which is formed due to the crystallization process. If that crystallization process takes place at a rapid rate, faster, that means for example when cooling of liquid substance or condensation of liquid substance takes place, then crystallization takes place, crystal formation takes place. And while crystal formation process, that process is a crystallization process. In this process, crystal formation takes place at a rapid rate, at faster rate. If crystallization takes place faster, then there is more defects produced in it. More defects are there. And if that crystallization takes place at slower rate, then defects are less. Less defects are there. That means if we have to create the crystal with minimum defects, we have to do that crystallization process at very slow rate. That means here, for example, if crystallization of sugar particles, if it takes place at slower rate, then it should contain very less amount of defects are there. But if crystallization takes place faster, then it creates more defects in that sugar crystal particles. Then we will discuss about the types of crystal defects which is produced in different types of crystals. That means the crystals we observe generally in everyday life, those are real crystals. Those are not the perfect crystals. Then there are crystal defects which is formed is of different types. Then we will discussing on the types of defects produced in the crystalline substances. Generally there are three main types of crystalline substances. 3 main types of crystal defects are there. Crystal defects are there. That is, first, point defect. Point defect. Second one, that is line defect. Line defect. And third one, that is plane defect. Plane defect. See here, all of you studied about that arrangement of the spheres takes place in the crystalline substance in one dimensional, which forms the row, in two dimensional on x and y axis. Then it is also takes place in three dimensional arrangement of those particles. See here, there are three dimensional arrangement of the particles takes place here. Then see here, if there is only defect produced at only one of the lattice point, that means if there is a irregularity produced at the arrangement of bases at lattice point, that means those are known as bases which are present at lattice point, and if there is the irregularity or defect produced at only one of the bases of that lattice point, then it is called as point defect. Then line defect, there is a defect in total row of the spheres. That means here there is defect produced in the total row of that crystalline arrangement of those spheres in the crystalline substances. Then that is known as line defect. Then if there is the defect in the arrangement of the spheres in the one of the layer, all of you studied about that in three-dimensional arrangement, there are different layers of those arrangement of the spheres are there in the crystalline substance, and if there is the irregularity in the arrangement of the first layer or third layer or any layer, then it is known as plane defect. That means here there are different three types of defects produced in the crystalline substances. Then in this chapter we have to discuss about only point defects. Then first of all we have to discuss on the point defect. Then what is point defect? This type of defect which is produced due to the irregularity which takes place in the arrangement of the basis of that means at only one of the sphere, one of the particle at present at lattice point in the crystalline substances is called as point defect. Then see here, if there is the arrangement of the particles or spheres in the crystalline substances, and if one of the particle is missing from that three-dimensional arrangement of the crystalline substances or crystalline substance, then that is called as point defect. Or if there is only irregularity in the arrangement of only one of the bases of the lattice point, then it is known as point defect. That means if there is an absence of sphere particles, or there is one of the extra particle occupies the interstitial space, then that are called as point defects. Then we will discuss detail about the point defects in this chapter. Then that point defects are again classified into three subtypes are there. Subtypes are there. That is first sachiometric defect. Second one, that is impurity defect. And third one, that is non-sachiometric defect. Generally, there are three subtypes of point defects are there: sachiometric defect, impurity defect, and non-sachiometric defects are there. First of all, we will discuss about the sachiometric defects or sachiometric point defects. Then, see here, the name itself indicates that sachiometry means, see here, in any compound, whether it is ionic compound or metallic compound, or it is covalent compound, or it is of, that is molecular compounds are there. Then in any compound, that compound which having that chemical formula of that compound which has a fixed ratio of number of atoms are there. Then see here, what is sachiometry? Sachiometry means any compound, whether it is metallic compound or ionic compound or molecular compound or it is covalent compound, then that any compound, the chemical formula of that compound which having a fixed number of ratio of their atoms are there, or there is a fixed ratio of anion and cations present in the ionic crystals or ionic solids are there. For example, see here, in NaCl, there is Na plus ions and Cl minus ions are there. Then there is a ratio of that cation is to anion, that is 1:1. In CaF2, Ca2 plus ion, that is cation, and F minus, that is anion, which having ratio of cation and anion is 1:2. That means here in NaCl, the ratio of cation and anion is 1:1. And in CaF2, the ratio of cation and anion is 1:2. Then that fixed ratio of that anion or cations or constituent atoms present in the any compound, if there is defect takes place, then that ratio of, if there is any defect, point defect takes place in any crystalline substance, whether it is ionic or it is molecular solid, then here in sachiometric point defect, that ratio of cation and anion or the ratio of number of atoms present in the crystalline substance, it remains the same. That means if there is a sachiometric point defect takes place in NaCl, suppose there is a crystal of NaCl which having the ratio of cation and anion is 1:1, and if there is a any point defect takes place in NaCl, then here ratio of that cation is to anion, that is 1:1, does not changes. That means it ratio of that cation and anion in ionic compound, it remains unchanged, though there is point defect takes place in it. As well as if it is covalent solid or molecular solid, then ratio of those particles of atoms which present in that crystalline substance, it remains unchanged. That means it does not changes, though there is point defect is produced in it. Then see here that stoichiometric point defect is of again 4 different types. That means here that 4 different types, which is a vacancy defect, then second one, that is interstitial, interstitial elemental defect is there. Third one, that is here Schottky defect, and fourth one, that is Frenkel defect. Then these all 4 types of defects is of stoichiometric point defect. That means there are 4 subtypes of stoichiometric point defects are there, and we will discuss about that all stoichiometric point defects with the help of diagram and examples in next lecture. Thank you.